Okay, today we're going to be looking at Newton's second law and weight. Newton's second law and weight. To kind of review what we were doing earlier, Newton's laws are about forces. A force is any push or pull. So if you have a tug of war, we have someone pulling 30 newtons to the left, and we have someone else pulling 25 newtons to the right. Because they're going opposite directions, you're going to subtract them. Your winner is going to be 5 newtons to the left. So you just take the big number, subtract the small number, and whatever the big number's arrow is, you choose that arrow. That's the direction it will go. And according to Newton's second law, the acceleration is going to be in the same direction as our force. This force, because we have multiple forces and we've added and subtracted, we have this called net force. Your net force and your acceleration have to be in the same direction. Acceleration has to be in the same direction as net force, but it does not have to be. That does not mean you have to be moving in that direction. So let's explain that. If I'm going to the right at 10 meters per second, and a force is applied in the opposite direction, say brakes, you will slow down. And what that can do is, we don't really have a math problem here, but the idea is I could then be going 8 meters per second. I slowed down going to the right, which means my acceleration was to the left. And that's the scenario we have over here on the left. So that's just what's going to happen. Your acceleration has to be in the same direction as your net force that's applied, but it doesn't mean you have to be moving in that direction. So there's not a lot of things that we try and trick you on. We keep telling you this over and over. Net force, acceleration have to be in the same direction, but that doesn't mean you have to be moving in that direction. You can be moving in that direction, but you don't have to be. All right, second scenario, 8 newtons to the right, 6 newtons to the left. Winner is going to be 2 newtons to the right, and that means your acceleration is to the right. What happens if you have a tug of war and each person pulls evenly? Well, we have no winner. So we have 0 newtons of force, and we have 0 acceleration, so we don't have a direction. Inertia, from our definitions on Newton's laws, is a property of matter that resists motion. Excuse me, it resists a change in motion. Okay, so logically, we all think about this and we go, anything that's really big is hard to move. Things that are really small are easy to move. And the reason is the term inertia. Weight is related to inertia, but it's not the same. Inertia is measured by the mass of the object. That's all of your elements and compounds that make you up. So all your hydrogen, your oxygens, your nitrogens, your calciums, your irons, all those things that make you up, that is your mass. That never changes. Gravity is what we're going to be talking about today in class. That will change based on the acceleration due to gravity. All right, so let's skip this stuff, which was from our previous worksheet, and let's look at Newton's second law. Newton's second law says force equals mass times acceleration. When he wrote this law, he wrote it as the acceleration of an object is proportional to the force applied and indirectly proportional to the mass of the object. So he's saying that if you apply a force to an object and it's a really big object, the acceleration is going to be small. If you apply a force to a small object, the acceleration would be larger. So, and that's common sense. So we've got a scenario here. He goes through all that. You know, what happens if you've got the same force, smaller objects, larger objects? You got a smaller force or bigger force, so we won't worry about that. Formula down here tells us all of our information we need for math. It tells us what the force is and what it's measured in, newtons. It tells us what m stands for, which is mass, and it says it's in kilograms. And it tells us the acceleration has to be in meters per second squared. So those are our units that we have to move it to if we're going to do our math. So if they give us our mass in grams, we have to find that mass in kilograms. Okay, so mass is how much stuff makes you up. Mass is the amount of matter in an object. So it's atoms and molecules. Weight is the force of gravity pulling down on the mass. So on Earth, your mass is going to be affected by gravity. Your weight is going to have to be larger than mass because it's going to be your mass times your gravity. So your weight, which is going to be the force of gravity, is going to be equal to the mass of the object times the acceleration due to gravity, which is g. We've studied this before when we did free fall. So g is 9.8. And this man, just to make things easy, is saying 9.8 is approximately 10. So 50 times 10 gives you 500. Mass in kilograms, weight is a force, so it's measured in newtons. Don't worry about this out here, it's incorrect. There is gravity in space. You appear to be weightless because of some other instances which I'm not going to go into in this video. The acceleration due to gravity is negative 9.8 meters per second squared. So if you have an object, it will be pulled down by gravity, and we can figure out that force being Fg equals mass times the acceleration due to gravity. This is just the same formula as force equals mass times acceleration. Just we're finding it based on gravity. Now, when you find your weight, have you ever got on a scale and found out that your weight is a negative, 205 pounds? No, we don't measure in negatives. We're going to make all of our weight positive. And the reason is, as you get on a scale and it gives you your weight, you're being pulled down by gravity, but you're not falling through the scale. The scale is pushing up, and what the scale is doing is measuring the force that it's pushing up with. So your weight is actually the force that the ground pushes back up, and so your weight is going to be a positive number. So weight here, the force of weight is going to be mass times g, the acceleration due to gravity. Notice that we're going to use a positive 9.8. Positive 9.8. So your weight will always be positive. So the reason we put this all on one worksheet is the force of gravity. I use F of g instead of F of w so that we'll understand that weight is the force of gravity on an object. And so we'll say that a force is any mass times the acceleration on that object. And so the force of gravity is the mass times g, the acceleration due to gravity. So then your math becomes fairly simple, concept-wise. Which will accelerate more if the same force is applied? A large object or a small object? To get more acceleration, it's easier to push a small object. So we choose between 10 and 15, we choose 10. Between 5 and 2, choose the small object. 2. Easier to move a small object. 500, 100, choose the smaller object. 50 or 5, choose the smaller object. Accelerate more with the same force. Now look to the right. It says which will cause something to accelerate less. So what's harder to move? Whenever you push something really hard or when you push something really soft? So this, we're looking at forces. So do you want to push really hard against something to get it to move less, or do you want to push really soft against something? We're going to push soft. So we're going to choose the smaller number in our scenarios. So that's how you're going to answer questions on this worksheet. Make sure you're reading what it asks you to solve for, and just think about in your life, do you push harder, do you push softer? Is bigger easier to move than smaller? And you have to pay attention if they're asking you if you need something that's going to be more of something or less of something. Let's look at this last one. A force of 10 newtons left or a force of 10 newtons right. Which will cause it to accelerate less? And the answer is neither. You have to be available to think about the idea that equal forces mean that our net force equals 0. And that means there's no change to our motion. That means if you're moving, you're going to continue moving, and if you're not moving, you're going to continue not moving. Remember Newton's first law, an object wants to do what it's already doing. If it's at rest, it stays at rest. If it's in motion, it continues in motion. Okay, I'm not going to go over the answers to the rest of the worksheet. We'll cover that in class. So go through and work the problems and then you'll be ready to solve some problems on force and acceleration and weight tomorrow. Thanks a lot.